How you doing? Long day? Been good? There we go. Right, slideshow. There we are. Hello everyone. She said, I'm Gaurav. I'm currently like a software developer with the School of Mining Engineering and Mineral Resources at Key-VFid. And let's get started with advancing mining education through AI-powered virtual labs. So scaling outreach into repeatable and interactive learning. So this will be our agenda for today. We're gonna go through outreach challenge. Okay, what things do we already have? What things we're gonna do and how we will be moving forward with the in-person things, the virtual things, and where does the AI comes into. We're gonna go over the solution that we have right now that we're working on, that is the virtual lab, and the AI chat agent that we're working on this thing. The virtual lab experience, I'm gonna give a demo. And then after going all of this, at the end, we have a beta testing that we're opening to everyone at SME at this point of time. So your feedback would be greatly appreciated. You can see on the right hand side, that's some of like our GIFs of how the virtual lab looks like. And let's deep dive in. Some more of it. So, transforming curiosity into comprehension. Okay, so what is the problem? Is there like a problem? I feel like in-person activities are great, they're amazing when people come, the kids, they come to in-person schools and facilitation centers, they play with all the different things, that we have at our mineral discovery workshop. Like this one you can see, that's a station over there, land reclamation. On the right side you can see that's a station for ore formation, where kids learn what metals goes inside the earth. What's like a magma chamber, how does like it works, and they get their hands dirty, just like you can see in our amazing picture, and they see, okay, how things work. But what about the people who cannot come and visit the facility in person? What about the people who are far away in like some rural location or some place where they don't have access to get to these places? So, what we are proposing is we're working on this interactive virtual labs, which is paired with a rack-based AI chat agent. I mean, apparently, AI is pretty trendy right now. And I will get into what is RAG and what chat agent we're working on and what we are doing with the virtual lab. So the impact that this thing creates is, like, as we all know, mining is a world-class education and it should be accessible anywhere, anytime, and it should bridge the gap between the remote and the underserved learners. What is the goal? The goal is to move from the fun moments to a more deep, measurable learning outcomes. For the kids, for the people, anyone in K to 12, even like if you're like in college and you're looking to change a career or you want to do something in mining, this is the thing for you, which is going to generate the curiosity. So these are like some stations that I told before reclamation and the ore formation. So let me tell you like a simple story. I joined the department last year. I didn't have any clue in mining. I'm like, okay, let's try this thing out. It's amazing. I saw that thing by myself. So I went to a lot of these workshops. I saw these kids. They came into, we have this mineral discovery workshop that we do at UFA. And I was one of the facilitators looking at how kids were doing different things and looking at different stations. I saw that kids come. They go to almost like 5 of the stations over there, or formation, where they learn about what goes inside the earth, what metals we have and all that. And along with this thing, we have land reclamation, there's metallurgy, electromagnetic, like we extract copper out of like, I think it was malachite. And some stations just like that. And recently we also introduced a new station, space mining, where we take a robo and like it goes over like a table. And if there's water at the particular spot, the light goes green. Boom, there we go. So that's what I saw. I was like, that is amazing, that's great. But what are the people who cannot make it in person? No worries. So we'll get there, but why does the traditional outreach fall short? I mean, it's great, and I agree with that thing. We should be in person and play with things to learn things better, because when kids screw around with things, that's how they learn the best. So I feel like there is some access gap, consistency gap, and the retention gap. Kids come, they have fun, they have amazing time, they're like in groups. But what if there are a lot of people in the room? How about if we have almost like 50 kids and we have just like 3-4 facilitators? I mean, it's amazing. Everyone will try to do their best to give as much as time as we can give to anyone over there, any kid, and answer their questions. And that's really amazing. But at times, it's not possible for everyone to be present in that physical location at the same time. And also at times, there are like different facilitators who have a different approach of teaching things, of telling things, and doing some experimentation. So what we're trying to do is we are trying to focus on K to 12 and anyone who is in STEM, maybe the community visitors, it could be parents, it could be any enthusiast who would like to visit like a STEM museum, or they have grandchildren, they want to like get their children into mining engineering or a STEM pathway. And this is also for the remote learners who are far away. So we're not trying to go statewide, we're trying to go nationwide and even global-wide at some point of time. So, as we all know, mining has a daily impact, and it is a foundational concept of modern life. It provides the essential raw materials, like we had in amazing presentations before this one, from smartphones to energy infrastructure and the future. There are a lot of things in STEM where people can do amazing things and accomplish great heights, like in engineering or go in medicine or anything like that. Then active learning. What is active learning? So basically, conceptual understanding deepens when we actively pursue something, when we look how things work, and when we do it, when we get our hands on that thing. That's how we exactly find a system, break it down into different modules and pieces, and learn how that thing is working. So, a paradigm for digital learning. Okay, now the virtual labs that we have, the first thing that we do is we provide a learn section where kids go, they learn about what exactly they will be learning into. Either that's formation, that's electrowinning, metallurgy, etc. Then we have the simulation where we have our interactive virtual lab, where the hands-on style learning it comes into, and this is a self-paced thing. Kids can go repeat this thing as many as times as they want to repeat this. And this is, we're working on creating like a high fidelity 3D environment. That means creating a simulation which is close to the real world. Along with this thing, the main thing of this session is we have our own AI chat guidance system inbuilt in this platform. And what that does, it works on the details that we have from our documentation as well as mining engineering and mineral resources. And when kids repeat this practice, they learn more, they get more curiosity, and then they get into mining. I will go over this thing briefly. Well, the framework that we use to create these virtual labs are, first the kids go, they explore. Then they do it, they observe it, and then they reflect of what they did. I believe in this one thing. There are 26 letters in the English alphabet. If you know half of it, 13, you can't make half the words. If you can't make half the words, you can't make half the sentences. If you can't make half the sentences, you can't make paragraphs. If you can't make paragraphs, you can't communicate. So it's better to know those other 30 letters than to know the entire Oxford Dictionary. So, learning, exploring what all things exist in mining and around in STEM, and then choosing a pathway which you want to go into or the kids want to go into. Okay, this is the fun part. So now we can go into the actual demo of our virtual lab and what exactly we worked on and what we will be moving forward with. So first we're going to go into our virtual lab roadmap, where we're going to see all the stations that we have in our platform. Then we're going to go briefly over the 3D mineral showcase. You can see it over here as well. These are like some of the minerals that we have at UFA, and we 3D scan them. Then we're going to finally get into our real-time AI support and how the platform works with AI. So this is our virtual lab roadmap hub. That's how it looks like. Virtual lab roadmap. On the left side, the first image that we have, you can see that these are like the stations that we have. We have ore formation, where kids go, they learn about earth. What elements do we have inside the earth, and how we can like do that magma bubble chamber simulation of what goes up, what comes down. I mean, how things work, mantle and convection and all that. Exploration. Kids go, they go and learn about how exploration geologists, they go and they can get out, they can get like the ore samples and figure out what mineral is in that particular location. Mine design, metallurgy, environmental regulation, lunar space mining, and we have one more that we added lately. It's sand filtering. If you see the image on the right side, we have when we hover or when we go over that particular segment over there, it gives us the information about what the students will be learning in that particular section. So when we click on this thing, so let's imagine we're clicking on metallurgy. Boom. Then we go into the learn page. In the learn page, we can see that what is metallurgy? What's the concept overview? What are the activities that are included in this simulation, in this lesson plan? After we go in this thing, then we get to the simulation part. So kids don't have any idea what they're getting into. Okay. First they're just looking into what I'm gonna click. Now they're like, okay, let's try metallurgy. The chemicals look cool over there. Then they're like, okay, now we are in the platform. Okay, what am I getting into? Metallurgy, sounds fun. Chemicals, sounds fun. Okay, let's get started. Simulation, let's get our hand dirty. Now they come to the simulation part, and the activity is to crush the ores. They actively click on the ores get into the mortar, and then they click this in pipeline. 1, 2, 3, 4, 5, boom. And we have our crushed ore fragments in the mortar. Now we take that, we move to the second step, and this is all automated, and it goes like in a sequential manner. So now the kids have to click on the diluted sulfuric acid. So when the sulfuric acid goes into the powder of our crushed ore fragments, it turns the solution from yellow to green. That means the copper ions dissolve, and the solution is now blue, just like that. So these hands-on activities and interactive learning gives them an opportunity to do these things as many as times as they want to do, and learn the things at their own pace, at their own time, and whenever they want to do this thing. Now, the last step in metallurgy is doing the electrowinning of copper. So now they connect the electrodes with the battery, they click on turn on 9 volt, and the copper gets electroplated on the cathode. And the kids get like a final message at the end that the metallurgy session has been completed, and they get a good understanding of how things work. Now, if they have any doubt, they can just go back to learn, figure this thing out by themselves as many as times as they want to. Okay, let's get into a bit of the 3D mineral showcase that we have. Okay, so this is one of the things that we have right now that we're also working on, the 3D rocks that we had at the university. We 3D scanned them. And these are interactive models of the same rocks which we scanned. You can go around, play with it, zoom it in, zoom it out, and just see how things look. Over there we have like an amethyst, and when we click on what's this used for, oh, this is a GIF for the likewise. So you can zoom that thing in, we can go around and see like how the things are, exact pixels of the rock, and that's how this thing works. So now, I'm like, okay, let me check what this thing is used for. I go into this, I see, okay, this is what it is used for. So this is all included in this platform which we have for 3D minerals and the rocks. And it includes everything, the common applications, what this thing could be used in, and everything like that. So far we have 23 total rocks that we scanned and we have in our collection. Okay, this is another station that we will go over like in brief. So this thing is the station 2, exploration. That's another simulation that we have where kids click on some of the areas over there and they get these samples. These are ore samples, and they also learn if it's profitable, if it's not profitable. There are like some formulas that we have on the back end, which we're still working on. Okay, the first virtual labs now, where is AI? So now the kids have a doubt. Okay, what's the objective of ore extraction? You can see on the extreme right, we have this little chatbot kind of thing over there. So this is our RAG-based AI chat agent, where we are getting kids all information. Now they're like, okay, what's the objective of the ore extraction? This is trained on a technology called RAG, Retrieval Augmented Generation Large Language Model. Just imagine like a chat GPT, but specifically made for education because it has all the data. For education, this thing doesn't go on the internet and it doesn't search the internet. This thing is specific, limited to a database, but it includes everything for these virtual labs. So kids, they don't get confused, they don't get some information that they shouldn't be getting, but they will get information that they actually want to get because it's all stored in there. And this is adaptive if you tell what age group you are in. Are you like in middle school, high school, or you're like in college? This thing adapts itself to all those functionalities and features. So that's how the AI works in. I want to go over a little bit over RAG. What's retrieval augmented generation? So basically, the kids, they come to this interface. In the interface, they type anything, that's the prompt that goes in. Then they have like a 180 billion parameters llama model, which is like open source large language model, just like ChatGPT, but by Meta in this case. Then it gets us a response based on the documents that we stored in our local database, which is a vector database. It's like a specific database with some specialized information, which like retrieves things pretty quick. And that's how the output that we get over there. So at the end, RagTech is getting an amazing response in the industry right now. And it's not limited only to education, but also to other fields. And this is guardrailed into some ethical consideration guardrails, so this doesn't go on the internet, so it don't give you any information. It gives you that specific information. Now the vision is to go, like expand from along with the statewide to also at nationwide, and then at the end of the day go global. Take this thing anywhere in the world and to give this thing to anyone. Doesn't matter where you come from, where you are. Let's collaborate. Let's get on the top together. So thank you for the presentation and the time that you guys gave me. Now let's do a fun thing. So that's our demo link right over there and the feedback form. If you scan that thing, we will go to the simulation site. It will take you to like a Google form. In that Google form, we will be having like some links over there, which will take you to the 3D interactive mineral site, and it will also take you to the virtual lab site. Then there's a Google form. If you like it, and if you would like to spend 2 to 4 minutes, whenever you feel after this session or right now, you can just fill that thing real quick. So we're beta testing at the moment, and we want to improve this thing and give it to any and everyone, and to also the universities, collaborate with them and make it a nationwide thing. But thank you. I cannot take any questions now.